All right, so let's continue with 1B. We are going to talk about what a complex number is. Obviously, this section is called complex numbers. So complex numbers include both real and imaginary numbers. Complex numbers. So the set of complex numbers, just like we can have a set of real numbers, complex numbers includes both real and imaginary numbers. So it includes all the real numbers that we usually deal with, but it also includes numbers that have i's in them as well. So complex numbers include both. Now, standard form for a complex number is in the form a plus bi. So make sure you write down what standard form looks like. Standard form is a plus bi. So a is the real part and b is the imaginary part. So an example, a couple examples of what a complex number could look like is we could have -2 plus 4i. This would be considered a complex number because it's in this form, negative, or it's in the form a plus bi. In this case, a is -2 and b is 4. It can also just be a number like -5. That just means the b part, the b is 0. So the a is -5 and the b is 0. So this is still considered a complex number because remember, complex number can include both real and imaginary. Or even if we just have something like -3i, that still would be a complex number because that means the a, the real part, is 0, and the imaginary, the b, is -3. Okay, so all of those would be included in complex numbers. And standard form specifically is written in this order. Okay. All right, so let's look at example 7. So write down number 7 if you're writing in your notes. Write in standard form. Here's the problem we're trying to do. 3 plus 3i plus 8 minus 2i minus 7. This is a complex number, but it's definitely not in standard form because it's not in the form a plus bi. All right, so let's write this in standard form. 3 plus 3i plus 8 minus 2i minus 7. So in order to write it in standard form, there should only be one a value or one real part. So I'm going to combine all the real parts. I have a +3, a +8, and a -7 that I'm going to combine. So it's basically like combining like terms. All the numbers by themselves, the real parts, are a like term. So 3 plus 8 is 11, minus 7 is 4. So the real part, the a, is 4. I also need to combine the b part, which is the imaginary part. So I have 3i and -2i. Those combine to give me a 1i. And it's a positive 1i, so it'd be 4 plus 1i. So that means the a is 4 and the b is 1. So we know we don't really, when there's a 1 as a coefficient, we don't really need to write it because it's in front of the I. You could also write this as the 4 plus I. Now, if you wrote it in the order I plus 4, that is the exact same thing, and it is technically correct. However, it's just not in standard form, because standard form is in the order A plus BI. So the A, the real part, should always be first. So even though this is correct, this is the way we want to write it if we write it in standard form. Okay. Now that we know what a complex number is and what standard form is, now we can do our operations. So on these examples here, we're going to be adding and subtracting. So to add or subtract complex numbers, we're going to add or subtract their real parts and their imaginary parts. So make sure we write down at least part of that if you're writing on your own paper. To add or subtract complex numbers, add or subtract their real parts and their imaginary parts. So this should look pretty familiar because it's basically like combining like terms. We combine the real parts and we combine the imaginary parts. All right, so let's do some examples, of course. All right, write down number 8. Notice the way these are written. 4 plus 7i is one complex number because it's in the form a plus bi, and 1 minus 6i is another complex number. So they're written in parentheses to show this is one complex number and this is the second one. All right, so write that example down. 4 plus 7i plus 1 minus 6i. So in this one, we are just adding. When we are adding, it makes it really easy because we just have to add the real parts and add the imaginary parts. So if I'm adding the real parts, I just have 4 plus 1, which is 5. And if I'm adding the imaginary parts, I have 7i plus negative 6i. Since that's minus 6i, we think of it as negative 6i, which is a 1i. So we have, and again, I don't have to write the 1, 5 plus I. Okay. So that's all we're doing when we're adding or subtracting. So I know you would have done this in Algebra 2. The adding and subtracting should be fairly simple. Adding especially. Now number 9, if we look at number 9, this one is subtracting. So with subtracting, we just have to be careful that we're actually subtracting the two parts. So I have 1 plus 2i minus 4 plus 2i. So write that example down. 1 plus 2i minus 4 plus 2i. And then let's subtract. Again, some of you might do this in your head. You might not have to write down the steps, and that's fine. Just be aware of your signs. Here we're subtracting the real parts. So I'd have 1 minus 4, and that would give me a negative 3 for the real part. Then for the imaginary parts, the two imaginary parts are 2i and 2i, but we're subtracting those. So I have 2i minus 2i. That just actually gives us 0i. You could write 0i if you wanted, but 0 times I or 0 times anything is just 0. So we wouldn't normally write that. So in this case, the imaginary part added up to 0. And so our answer on this one's just negative 3. Another way to think about subtracting is you can distribute the minus or the negative to both of these. So we'd have a minus 4 and a minus 2i. You can think of that way as well. Okay. So if we look at 10 and 11, it's still adding and subtracting. So number 10, we have 3i minus negative 2 plus 3i minus 2 plus 5i. So we're subtracting two different complex numbers. And on 11, we have adding and subtracting. But notice there's 3 complex numbers in each one. All right, so let's do number 10 first. So write down number 10. 3 minus negative 2 plus 3i minus 2 plus 5i. So there are a few ways to think about this. The first imaginary number here, the real part is 0. So if you wanted, you could use a 0, and then we'd be subtracting -2, and then we'd be subtracting 2. Or we can also just think of this kind of like we would with polynomials. This is like, since we're subtracting, it's like we could write a 1 in front of either of these complex numbers. And if you prefer, you can also think of it as distributing the -1 to each of these. Okay, so I've got that's the way I'm going to do it, since there's multiple factors here, or multiple complex numbers. So I have the 3i in the front. If I am subtracting a -2, that would actually become a +2. And then I'm subtracting a 3i, so that'd be -3i. Or you can think of it like distributing a negative. And then here I'm subtracting 2, and then I'm subtracting 5i. Okay, once I have the correct signs on everything, I can combine the real parts. In this case, the real parts are +2 and -2, so the real part adds up to 0. And then the imaginary part, I have 3i, -3i, and -5i. So +3i and -3i adds up to 0, plus -5i would be -5i. So if you wrote it with the real part, we'd have 0 minus 5i, but we don't really have to write the 0. So we would just write -5i. Again, all of these numbers, 5 plus I, -3, or -5i, are still all complex numbers, because complex numbers include both real and imaginary. Right. Last one with adding and subtracting is number 11. So write down example 11. We have 3 plus 2i plus 4 minus I minus 7 plus I. 3 plus 2i plus 4 minus I minus 7 plus I. Now, just like when you're adding, you can add the first two together and then subtract, or we can do like we did on number 10 and simplify all the signs and then combine all the real parts and all the imaginary parts at once. So I'm going to go ahead and do that. The first one here, 3 plus 2i, I'm going to just write it without the parentheses around it, because I have a +3 and a +2i. Then I'm adding a 4, so that'd be a +4, and then I'm adding a -i. So here, this is like a 1 in front, and it's a +1. So that'd be a +4 and still a -i. Now right here, you got to be careful with your signs, because we are subtracting a 7, and then we are subtracting an I. Okay, subtract 7, subtract I. Or you can think of it like a -1, and so we get a -7 and a -i if we distribute that. Okay, so after I simplify all the signs I have, I can combine all the real parts. The real parts, I have +3, +4, and -7. Again, that adds up to 0. And then if I add the i's, I have 2i, -i, and -i. +2 minus I is I minus I is 0. Technically, if you wanted to write it in standard form, we could write it as 0 plus 0i, but there's no need to write that. 0 times I is just 0, and 0 plus 0 is just 0. So rather than writing 0 plus 0i, I can just write 0 in this case. Okay, so if we look at these, we see quite a few different ways that that our answers can look. But oftentimes they look like this, where they have a real part and an imaginary part. So let's keep going and do the multiplication, and then we'll do practice with adding, subtracting, and multiplying. Because I'm guessing most of this stuff will look fairly familiar to you from Algebra 2. Okay, so let's continue to multiplying. So to multiply complex numbers, we're going to use the distributive property to multiply. So it is not like adding. You don't just multiply real and multiply imaginary. You actually have to distribute. So you have to use the distributive property, which means you can also use the box method on some of these. Okay. So to multiply complex numbers, so make sure you write that down somewhere. Use the distributive property to multiply two complex numbers. And then, of course, let's do some examples. All right. So number 12, we're multiplying 4 times -2 plus 3i. So write down number 12, 4 times -2 plus 3i. So on this one, we're just multiplying by a number that just has a real part. So here it's easy to just use the distributive property. So I'm going to distribute that 4 to both of these. So I'm multiplying both of them by 4. So if I do that, 4 times -2 is -8. 4 times 3i is plus 12i. And now that's in the correct form because it's in the form a plus bi, and that's it. So that was pretty easy. We just had to distribute the 4 and we got -8 plus 12i. Now, the rest of these, notice that all of these, we're going to end up doing an I times I. So before we do that, I just want to remind you that I squared, we talked about this yesterday, I squared is equal to -1. So anytime we have an I squared, we're not going to leave I squared in our answer. We're going to replace it with -1 so that we can write our answer in standard form. Okay, so let's look at 13. Everybody write down the problem for 13. We have 2 minus I times 4 plus 3i. I know they're multiplied because the parentheses are just next to each other. There's no symbol in between. So I know they're multiplied. So 2 minus I times 4 plus 3i. So as we know, we have to distribute. So one way you can think of it is you can distribute the 2, and then we also have to distribute the -i. So you have to multiply both things by 2 and then multiply both things by -i. Most of my students prefer to use box method just to keep our work organized. You don't have to use box method if you like the distributive property, but I'm going to show you what this would look like with the box method. So I would make a box. On one side, I'd have 2 minus I, and the other side, I'd have 4 plus 3i. So I'm setting up my box for box method. Then I'm going to multiply the numbers on the side. So inside the box right here, 4 times 2 is 8. In this box, I have 4 times -i, so I just write that as -4i. In this box, 3i times 2 would be 6i. Now in this box, we got to be careful because we're doing 3i times -i. That's like a -1i. So for the number, 3i times -i would be -3. Now for the I, we have I times I, So we actually have 3i squared. That is really important to pay attention to. Okay, so when I multiply this, I times I, I'd have negative 3i squared. Just like when we multiply polynomials, we can usually combine the diagonal. I have a negative 4i and a 6i. So I'm going to combine those. Here's what I have. I have the 8. I have negative 4i and 6i, which is plus 2i. And then I have negative 3i squared. Okay. We are correct so far, but this is not in the correct form that we want to end in. Remember, we want our answer to be in standard form, a plus bi, which means I need to simplify the I squared part. That's where this comes into play, the fact that I squared equals negative 1. So let's simplify this. I have negative 3i squared. This would still be like a negative 3. It's like negative 3 times I squared. So this would be like a negative 3 times negative 1. And a negative 3 times negative 1, because I squared can be replaced with negative 1. Negative 3 times negative 1 would become positive 3. So this term just simplified to positive 3. Now that it's simplified, I can combine it with the 8. So you have to simplify the I squared term, and then you can combine it with the other number term. So now I can combine 8 and 3. So our final answer would be 11 plus 2i. Okay. So that's the thing. So even though right here we had, this was still correct when we had 8 plus 2i minus 3i squared, we had to simplify more. We had to, anytime we see an I squared, we replace it with negative 1. That way we can write our final answer in the form a plus bi. All right, so let's look at 14 and 15 are kind of a little bit of special cases, some things that are important to notice. All right, so let's write down number 14. 14, we have 3 plus 2i times 3 minus 2i. 3 plus 2i times 3 minus 2i. You might notice these are have the same numbers, 3 and 2i, but one has a plus and one has a minus. That's a really important property. Those are actually called conjugates, which we'll talk about more when we divide. All right, so 3 plus 2i times 3 minus 2i. If you prefer, you can set this up with the box method, or you could just use distributive property. I'm going to set up box method. So 3 plus 2i and 3 minus 2i. So inside my box, this would be 9. This would be 6i, 3 times 2i. This box, negative 2i times 3 would be negative 6i. And then this fourth box here in the bottom right, negative 2i times positive 2i is negative 4 for the number, but I times I is negative 4i squared. Okay, then if we combine like terms, the only like terms we have right now are the 6i and the negative 6i. Notice though, what do those add up to if I have a positive 6i and a negative 6i? Those are just going to add up to 0. So I don't even have to write it down. That is always going to be the case when we're multiplying by the conjugate. So now I have 9 minus 4i squared, because these added up to 0. But this is not my final answer, because I have to simplify the I squared term. So this is minus 4. Remember, I squared is negative 1. So this becomes negative 4 times negative 1, which becomes positive 4. Now I can combine the positive 9 and the positive 4. And so my final answer is 13. this is really important to notice. When we multiply by a conjugate, where they have the same terms, but different signs in between, the i's will always cancel out and add up to 0, and we'll always be left with a whole number. So that's going to be a really important thing to notice for dividing. Okay, almost done for the moment, and then we'll do some practice problems. So 15. 15, we have 3 plus 2i squared. This is different than 14. So write down problem 15. The quantity 3 plus 2i squared. So a common error on these kind is people just want to square the 3 and square the 2i. That would not be correct, because something squared means multiply by itself. So I actually have to multiply out 3 plus 2i times 3 minus 2i. Oh, kidding. Never mind. 3 plus 2i times itself would be 3 plus 2i times 3 plus 2i. I totally said that wrong. So 3 plus 2i times 3 plus 2i. Once we have it written out like that, again, you can use the box method if you prefer. I'm going to set it up with box method. So notice this one's 3 plus 2i and then 3 plus 2i again. They're both plus 2i. So if I multiply this will give me 9 plus 6i. This will give me plus 6i or positive 6i, and this will give me plus 4i squared. Okay. Oh, if I combine the like terms this time, they're both a positive 6i and a positive 6i. They do not add up to 0. So here's what we have so far. We have 9 plus 12i plus 4i squared. Okay, so this time we combine those. They didn't add up to 0 because they're not opposites. They added up to 12i. Right. So this is where we're at, 9 plus 12i plus 4i squared, but that's not correct. Or not finished, I should say. It is correct, just not finished, because the I squared needs to be replaced. And I squared is equal to -1. So this time we had a positive 4 times a -1, which would be a -4. Now I can combine the 9 and the -4. And so we would get 5 for the number part, and then plus 12i is the imaginary part. So on this one, the i's, because they were both plus 2i, did not add up to 0. And then we still had to simplify the I squared part. Okay, so with multiplying, we have to use distributive property, which we could use box method to help us with that. But the key thing on all of these is they all had an I squared on 13, 14, and 15. And we had to use this fact that I squared is equal to -1.